Hi everyone, and welcome to the Mat 211 review on linear programming. My name is Julia, and I work for the tutoring centers at ASU. So for our problem, suppose that we have z equals 3x plus 4y, and this equation is subject to the following system. 2x plus 2y is less than or equal to 14. 3x minus y is greater than or equal to 0, and x minus y is less than or equal to 5. And we want to find the max and min of z. So first things first, we can treat this set here as sort of a solution space. So we have the values in here, and we're bounding our values that we're going to put in our equation here by these functions, by these inequalities. So the first thing we want to do is we want to graph the solution set of our system of inequalities. But these are not in the best form for graphing, so let's just clean them up a little bit. We'll set them all, solved for y, so that they'll be as easy as possible to graph. So for this first guy, we'll write it down here. We have 2x plus 2y is less than or equal to 14. Well, we can divide by 2 across. That gives us x plus y is less than or equal to 7. And then we can just subtract this x over to the other side, which gives us y is less than or equal to 7 minus x. So let's write that over here. Make a little space for it. All right, so for our second, we'll do the same thing. We have 3x minus y is greater than or equal to 0. First thing, we'll subtract our 3x over to this side. So that gives us negative y is greater than or equal to negative 3x. Now we want to multiply both sides by -1 so that we get rid of this negative in front of our y. But remember that when we multiply by a negative in an inequality, it switches the direction of the inequality. So we'll have y is greater or less than or equal to 3x for this one. Okay, so we'll write that up here. Y is less than or equal to 3x. And similarly, same step on this one. We won't go through that one, but feel free to check it at home. We have y is greater than or equal to x minus 5. Okay, and that again, we switch the sign because once we subtract this x over to this side, we have to multiply by a -1 in order to get y by itself. So now that we have them in a nice graphable form, we can treat each of these inequalities as an equality to graph the line of just the equality itself. So for this first one, we have y would equal 7 minus x. So if we say that 7's somewhere up here, right? Let's make that a line instead so it's clear it's not a point. 7's up here, that's our intercept, and minus x. So we would have at the point where x was equal to, or y was equal to 0, well, we'd have something like this going this direction. So if this is equal to 0, then we would have 0 is equal to 7 minus x. If we add x over here, we have 7 equals x. So really this line is a little bit less slanted than this. It's more like something like that. Okay. So for our next, we're going to look at this y is less than or equal to 3x. And again, we're going to treat it as y equals 3x. Well, this implies that our intercept is at 0. So we'd start somewhere over here. And we'd be going up for every one, increment that we go in this direction, we go 3 in this direction. So we'd be going up something like that. Rough drawing here, that's probably not perfect, but you get the idea. So let's label that too. Let's say that that is y less than or equal to 3 of x. And we know that since it's less than or equal to, it'll be down here. So for our third, we want to do y is greater than or equal to x minus 5. So we're going to have x minus 5, or minus 5 is going to be our intercept. So let's say that's somewhere down here. And we're going up, again, kind of a 1-to-1 slope here. So we're going up something like this. Good enough. You guys get the idea. So we'll call that one, just label that so that we don't get confused. Y is greater than or equal to x minus 5. And let's label our first one too. So we've got y is less than or equal to 7 minus x for this one. Well, let's connect our points here just so it's kind of clear where we're going. Something like that. Bad drawing, but you get the idea. So now we want to think about where our solution space is with respect to these 3 different inequalities. So for our first inequality here, we've got y is less than or equal to our line. So we know we'll be somewhere down in this region, right? For our second line, we also know that y is less than or equal to 3x. So that implies that we're over here somewhere. So let's get rid of this line here because it's not part of our set anymore. And then for our third, we have y is greater than x plus 5. So greater than this line here. So that means it's up in this space. So we'll just scribble that in, clear up our extra lines here that don't belong here anymore. And that's going to be our solution space, is that bounded solution space in between our 3 inequalities. So since our solution set is bounded, this means that there will be a min and max for our z function here. And it will be one of these corner points. So these 3 intersections between our different inequalities. So the way to find what our max and min of z is to find each of these corner points and then plug it into our z equation here and figure out which one is the greatest and which one is the least. So let's start with this point here, okay? And for that one, we have the intersection between y is less than or equal to 3x and y is greater than or equal to 5x. But we're going to treat these as just the lines for right now because we only care about the lines, so just the equality part. So we're going to have the intersection between y is equal to 3x and y is equal to x minus 5. So we can connect these by noticing that they each have a y on each side. So we would say that 3x, well, we know that equals y, but we also know that that equals x minus 5. So we can just get rid of the middleman here and say that 3x equals x minus 5. So now we want to solve for x. So if we subtract our x from this side over to here, we've got 2x equals minus 5. And then that gives us negative 5 over 2 equals x. So now we can take this and we can add this value here for x, and we can stick it in our equalities for either here or here to solve for our corresponding y value. So we have, let's use this one. We have y equals x minus 5 but we're going to put in our negative 5 over 2 for our x here, so minus 5. And we could say then, to get these to have same common denominators, we'll have negative 5 over 2. Ooh, this looks terrible. Let's move this down. There we go. Y equals negative 5 over 2 minus 5 times 2 on the top, so 10 minus 10 over 2. And that gives us y equals negative 15 over 2. So our point here is going to be negative 5 over 2 and negative 15 over 2. Okay? So we're going to do the same thing for both of these intersections too. Let's go through one more. So we'll clear off some space here. Let's look at this second corner point up here. And that's the intersection between the lines. So we're, again, not going to look at the inequality here, just the equality. Where the lines y equals 7 minus x and y equals 3 of x over here. So again, we're going to do the same thing, set them equal to each other. So 7 minus x equals 3x. We can add an x to both sides to get rid of it on this side. That gives us 7 equals 4x. So then, if we divide over our 4, we have 7 over 4 equals x. Again, plugging this into one of the equations, let's use this guy. Y equals 3 of x. So y equals 3 times 7 over 4. And that gives us 21 over 4 for our y value. So this point here is going to be 7 over 4 and 21 over 4. Okay? Same process will work for this one. We have y equals x minus 5 and y equals 7 minus x. I'm not going to go through it a third time, but this point ends up giving us 6 and 1 for our third point here. So now that we have our 3 points, let's make some space again, and we're going to plug each of those into our equation here, our original z equation here, and figure out which one gives us the biggest value and which one gives us the smallest value. So let's start again with this guy. So we've got z, that's a z, equals 3 times x, so x is negative 5 over 2 in this case. And then plus 4 times y, which is negative 15 over 2. And if we simplify these a little bit, we get negative 15 over 2 plus, well, minus in this case, because we got the negative sign from our 15 here. So minus 60 over 2, which gives us minus 75 over 2. And if we just take the decimal version of that, that gives us negative 37.5. So that's for our first value here. We'll just mark that as first. Boop, 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 boop. Let's try it again for our second point. So we've got z equals 3 times 7 over 4 plus 4 times 21 over 4. So these guys cross out, so we don't need to do that. That gives us 21 over 4 here, plus 21. Well, we do actually want to get this and to have the same common denominator as this fraction. So we will go ahead and multiply it by 4 anyways. So that gives us 21 over 4 plus 84 over 4. And if we add those together, that gives us 105 over 4, which equals 26.25. Oops. Let's draw that box a little better. There we go. So this is our second point. And same thing, same process for our third. C equals 3 times 6 plus 4 times 1, which is 18 plus 4, which equals 22. And that's our third point. All right. So looking at these three values, we can see that our lowest value is at our first point here. So this guy here. So this is going to be our min. So that's going to be the coordinates that generate our min. And our min is negative 37.5. And our max value is this second point here, 26.25. So we know that it's going to happen at 7 over 4 and 21 over 4. So our max will equal 26.25. All right, and that's it. So let me go clear this and move to my next screen. So lastly, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, you can go to tutoring.asu.edu to find all of our various services. So that's this guy here. And if you go right to this link, Tutor Search, it'll bring you to the Tutor Search tool, which allows you to find tutoring services for your particular course. So you can just plug in your course information and it'll give you a list of our services and times. Thank you so much and have a great rest of your day.